Hello students and welcome to the quick solution of All India Cast Test Series JEE Main 2020 Test 3 Code C&D Physics. Let's move to question number 1. In question number 1, a uniform triangular plate of mass m as shown in figure, the moment of inertia of plate about indicated axis is. So this is the plate and we have to calculate the moment of inertia of this plate about this axis. So if I draw this plate in this way, this is also a plate of mass m, this is another plate of mass m, and this is the last plate of mass m. So if I required the moment of inertia of this plate about this axis, then I can say that the net moment of inertia of the extended plate about this axis can be written as 4 times I required, and that is equal to the moment of inertia of this complete plate about this axis. So about this axis, the moment of inertia will be m into a square by 6. So about this axis, the moment of inertia will be m into a square by 12, where m is the total mass of this extended plate and a is the edge length of this square plate. So this edge length a is equal to root 2 L. So if I write this is equal to 4m into edge length is root 2 L whole square divided by 12. So if I solve this, the I required comes out to be ml square by 6. So option 4 is the correct answer. So the correct answer for question number 1 is option 4. Let's move to question number 2. In question number 2, a particle of mass 1 kg moves in such a way that its speed v varies with distance s covered, as v is equal to 2 times under root s, where v and s are in SI units. The work done by all the forces acting on the particle in first 10 seconds is, by applying work energy theorem, the work done by all the forces is equal to kinetic energy final minus kinetic energy initial. Now I have to write what is the kinetic energy. So let it is given that v is equal to 2 times under root s, or I can write ds by dt is equal to 2 times under root s. Or from here I can write ds by root s is equal to 2 times dt. So at t equal to 0, s is 0, and at any time t, s is s. So this will give 2 root s is equal to 2 into t. So we know that v is equal to 2 root s, so this is equal to v. So v is a function of time is equal to 2t. So at t equal to 0, initial kinetic energy is 0, and final kinetic energy can be written as half into m into v. So at t equal to 10 second, velocity become 20, so it is 20 square. So it comes out to be 200 joule. So option 4 is the correct answer. So the correct answer for question number 2 is option 4. Let's move to question number 3. In question number 3, a body of mass m is slowly moved across a hill by applying a force F, which is always directed along the tangent to the surface. The height of the hill is h and its base length is L. The coefficient of friction between body and the surface is mu. The work done by the applied force F is. Since the body is slowly moved across the hill, so gain in kinetic energy is 0. So by applying work energy theorem, I can say that work done by applied force plus work done by gravity plus work done by friction plus work done by normal is equal to 0. Since work done by normal is always 0, as the block always moves tangential to the surface, so I can write work done by applied force plus work done by mg plus work done by friction is equal to 0. Now the work done by gravity is also 0, because as the block moves up the hill and down the hill, then the work done by the conservative force is 0. So I can say that work done by applied force is equal to negative of work done by frictional force. Now I have to calculate what is the work done by frictional force. So let this block move from this position to this position by a distance ds, and the angle made by the horizontal is let theta. So I can say that the work done by friction dw is equal to mu mg cos theta, that is the frictional force, into ds, and negative of this. So as the block moves from this position to this position, the work done by friction is this much. So if I see the geometry, ds cos theta is the horizontal component of this displacement. So I can write ds cos theta as dx. So minus mu mg into dx. So as the block moves along this path, then the work done by friction is equal to integration of dwf, and it is equal to minus mu mg into dx. So its integration gives this length, so multiplied by L. So I can say that the work done by applied force is equal to mu mg into L. So option 2 is the correct answer. So the correct answer for question number 3 is option 2. Let's move to question number 4. So in question number 4, a uniform chain of mass m and length L rests on a rough table such that one of its ends hangs over the edge. The chain starts sliding off the table by itself when overhanging part is equal to L by 4. The total work done by the frictional force till the moment the other end of chain slips off the table is. So initially, when the chain is in the state of equilibrium, the overhanging part is equal to L by 4. So at that moment, so suppose if mu is the coefficient of friction of this surface, then the remaining part is 3L by 4. So we can write the limiting value of the friction at that instant is mu into 3m by 4 into g. This is the value of friction which is acting on the chain, that is equal to m by 4 into g. So from here the value of mu comes out to be 1 by 3. Now we have to calculate what is the total work done by the frictional force. Suppose the length of the chain which lies on the table is x at any time t. So this is x. So at this moment the friction which is acting on the chain is F is equal to mu into m by L into x, that is the mass, into g. So this is the frictional force acting on the chain in this direction. So in time dt, let the chain further moves downward by a distance delta x, then the work done delta w by the friction can be written as minus mu into m by L into x into g. So this is the friction into delta x. So now in order to convert this equation in the differential form, delta w is equal to minus of mu m by L x into g. This delta x is replaced by minus differential x final minus x initial. So we are measuring x from here. So the final length of the chain is less than the initial length of the chain on the table. So dx itself is negative. So I am writing delta x is equal to minus of differential x, as delta x is a positive quantity. So this is equal to, now the total work done by the friction can be written as integration of dw. So variable here is x, and the initial value of x is 3L by 4 and final value is 0. So if I integrate this, it comes out to be minus 3 by 32 mg into L. So option 2 is the correct answer. So the correct answer for question number 4 is option 2. Let's move to question number 5. In question number 5, a particle of mass 1 kg is moving along a circle of radius 2 meter. If centripetal acceleration AC of the particle varies with time t as AC is equal to 3t square, where quantities in equation are in SI units, the average power delivered to the particle during t equal to 0 to t equal to 10 seconds. So it is already given in the question, centripetal acceleration v square by r, the value of r is 2, this is equal to 3t square. So from here the value of v comes out to be root 6 into t. So if I calculate dv by dt, rate of change of speed with respect to time, that is tangential acceleration, that comes out to be root 6. So from here tangential force is equal to mass, that is 1 into root 6, tangential acceleration, that comes out to be root 6 Newton. Now I have to calculate the instantaneous power. So the instantaneous power is equal to tangential force into velocity at that moment. So it is the product of these two things. So if I multiply this, it comes out to be 6 into T. So in the question it is asked, what is the average power delivered to the particle during T equal to 0 to T equal to 10 seconds. Since P is directly proportional to T, so it's a linear relationship between power and time. So average power can be written as P initial at T equal to 0, that is 0, plus P at T equal to 10 second, so that is 60 divided by 2. So it comes out to be 30 watt. So option 3 is the correct answer. So the correct answer for question number 5 is option 3. Let's move to question number 6.